I'm going to prove that not all Etch-a-Sketch rotations are isometries. So before we begin, we need to understand the definition of both rotation and isometry. With rotations, you are to pick a point that needs to be rotated along with the center point in which you rotate it around. An isometry is something where the distance is preserved every single time. So the distance will never change. It always stays the same. So for the example, we are going to use the points 0, 4, and 2, 0. I placed them on the graph right here, as you can see. 0, 4, 2, 0. Now we're going to find the distance between these two, so I'm going to connect them. And we're going to try and find the distance of this line. So within Etch-a-Sketch, to measure the distance, you just count the number of spaces it takes to get from one dot to the next. So here we start at 0, 4, and we're going to go down 1, 2, 3, 4, and over 2, 5, 6 to get our distance of 6. So between the point 0, 4 and 2, 0, the distance is 6. So I would like to rotate this 1/8 of the percentage around the circle counterclockwise. This is what I'm choosing to do. So here I have my graph with my original points, 4, 0, and 2, 0. Or sorry, excuse me. This should say 0, 4. My mistake. 0, 4, and 2, 0. And I'm going to draw a circle, an Etch-a-Sketch circle around both of them. So from 0, 4, the circle would be, with the radius is 4, so every point within the radius is going to be 4 away from the center. Same thing with this one, 2, 0. The radius here is 1, 2, so every radius or point from the center is going to be 2. Now, when I rotate it 1/8, it's only going to be half of this side of the graph because there's 4 quadrants, and half of 1/4 is 1/8. So with my 0, 4, I'm going to rotate it 1/8, and I get to the point -2, 2. So I'm drawing that. And I know that it's correct because it is still within on the line on my circle. And then on my second little circle, 2, 0, if I'm rotating it counterclockwise, I'm going to the left, and halfway would be the point 1, 1. So now I have my two circles with these 2 points. And now I'm going to connect these. So my new points are -2, 2, and 1, 1. So to find the distance, I can do a simple equation by subtracting and using the absolute values. So I would do -2 minus 1, here, the x's, plus 2 minus 1, the y's, coordinates. And -2 minus 1 is -3, 2 minus 1 is 1. Keep those in absolute values. I get 3 plus 1 equals 4. So my distance between these 2 points is now 4. Another way to check that is by doing the Etch-a-Sketch counting. So I would go over 3, 1, 2, 3, and down 1, 4. So I know that my new rotated distance is 4. Now, looking back, the original distance between the unrotated circle was 6, and the new distance is now 4. So this hereby proves that it is not an isometry because, according to the definition that states that all isometries have to have the distance preserved, rotations are not always isometries because the distance here changed when rotating it 1/8.